Hey guys, welcome to the channel. This is Waga. We're going to do another LeetCode question. Question in question is number 103, binary tree zigzag level order traversal, right? So we have a binary tree, you're supposed to return it in zigzag level order. What that means is we start off with the root, and then we start, if the root has children, we start by adding the right node and the left node, and if the and when we come to the next level, the level after that, if they have children, we start by adding the left node and then the right node. So in this case, where we have 3, 9, 20, 15, and 7, we have 3, then we add 20 and 7 and 9 as their own level, and then afterwards we add 15 and 7 as their own level after that, right? So our answer should be 3, 29, 15, and 7, right? What we should do in such a situation, we could use a DQ, right? And in a DQ, we can add items from either the front or the rear, or the left and the right, right? So, or the back and the front, right? So, for example, if we come here and we create this situation, what we could do is, if we have our array, we have the array is going to be just going to be basically not our array, the tree is going to be 3, 9, 20, 15, and 7, like so. And we could create an array of levels where we collect a DQ of levels where we collect every single level. And another thing we could have is a result array, right? So a result array. And depending on whether the zigzag flag, we could have a flag, we could call it maybe zigzag. Depending on the flag, we decide where we're going to add the children of a node to an array, right? So for example, if we have the case of having our tree, we have our tree which is 3, 20, 19, 15, and 7. We add, the first thing we do is we append to our queue. In this case, we append to our queue. We could have a queue here, and we append to our queue our root. We say maybe 3, and after that we pop the 3 and we put all the children into a level, right? So we put all the children in the level, and then progressively add them to our queue depending on whether the flag is right or is true or false, basically, right? It's pretty straightforward, and it's I think easier understood when you actually put it in code, right? So we could start off, the first thing we could do is we could have a sanity check, right? We just check that everything is as it should be. We could say if not, root, and what we want to do in such a situation, we want to return an empty array, right? We return an empty array like so, and then afterwards we create a results array, and the results array is just going to be empty like so, and afterwards we get the queue, and the queue is just going to be collections, and we could say dot DQ like so, right? So we have our queue over there, and then we have our flag. We could call it zigzag, and our flag is going to be set to false. And if it is false, we start with we start by appending the left child, right? If it's true, we start by appending the right child, right? So depending on what is what, whether the flag is, we're going to append to our queue depending on the quality of what the flag is, and then obviously we're also going to have to flip the flag at some point, right? So basically that, right? So what we do is we have to flip it at every single level, right? So we could start off by appending our root, right? So q.append, and what we want to append is going to be our root, like so, right? And the next thing we need to do is we could have a while loop. While there's something in our queue, we could have a level. We could create an array to hold our various levels so that you can add them together. And the first thing we check is we loop through the length of the queue, and for that we say for underscore in the range, and the range we want to look at is the length of the queue. And of course we start off with the queue having our root, which we just appended, right? And we check the flag, if zig, let's just spell it correctly, if zigzag, what we want to do is we want to first remove the remove the node in our queue, and then append to the levels, append to our level the node, the actual node, and then add to our queue the children. And this is the order we're going to add them. We're going to add the right children and then the left children, and we're going to use the append left method, right? Like the first thing we do is we pop what is in our queue, which in this case, if we're starting, is the root, right? So we say node is going to be queue dot pop, right? And after we pop it, what we want to do is we want to append to our level the value of the node, right? So we say level dot append, and what we want to append, the value of the node, right? Node dot val, like so, right? And then the next thing we do is we check whether or not the node has a right child, because the zigzag is true in this case. So we check whether the node has the right child, like in this case we add 20 and then 9, right? So the first thing we do is we say if node dot right, does it have a right child, right? If it has a right child, what we want to do is we want to put to the left of our queue the node's right child, right? So what we do in such a situation, we come here and we say queue dot append, and what do we want to append? We want to append the left, right? So we want to append left, rather. We want to append left, and we want the right child, right? Node dot right, like so. And after that, we check if it has a left. We say if node dot left, and we append queue dot append left. And what do we want to append left? We want to append left the left child, right? So we say node dot left, like so, right? Else that is zigzag is false, like on this third level, right? What we do there is the same thing. We just we first pop our node. We say node equals queue dot pop left, right? We remove on our queue, right? We remove the we pop it on the left, right? We remove it from the left side, right? And after that, the next thing we do is we append it. We just do the same thing here. We just append the value of the node that we popped off, right? So you could copy this line, copy, come and paste it here, like so, right? And it came with a bit of space in it, so we just append that value like so. And afterwards we check if it has a left, and we put it on the right, and we do the same for the right, right? So we say if, let's just type it out, if node dot left, what we want to do is we want to append queue dot append, and what we want to append is the node dot left. And after that, we want to check if node dot right, and what we want to append is queue dot append, and we want to append the right, right? So node dot right, like so, right? And afterwards, after these two have run, the next thing to do is just put the level into our result, right? So for that, we come and say, after the if checks have run through, we just want to put that specific level to our result. We could say results dot append, and but we want to append the current level, right? Like so. And then afterwards, we want to set our zigzag to the opposite of what it is, right? If it's true, it's false. If it's false, it's true. Like over on the other channel, I use Swift UI. In this case, it would be a toggle switch. If you know Swift, right? If you know Swift UI, right? This is basically a toggle switch, right? So we say if a zigzag is going to be not zigzag, right? The opposite, right? And finally, the next thing we do is outside the while loop, we just need to return our result, like so, right? We make a few corrections to a few typing errors, and we make sure that our res and our zigzag, the flag, are on the for level of the loop, right? And after that, we run our code, and if we run our code and we submit it, it should be accepted, right? So basically, it has been accepted, and the time complexity is obviously going to be O of n because we go through n nodes, and the space complexity is going to be O of n because we create structures that are potentially as large as the lists that as large as the tree, right? We'll have as many elements as the tree has nodes, so potentially that. So yeah, so it's O of n. So thank you for watching, subscribe to the channel, and I'll see you in the next video.